morning, guys. Last section of chapter 11 here, some applications of rational functions. These aren't too intense. The applications in the next chapter of rational functions are going to be much more intense than these are. But we'll baby step into it. Today, like I said, is 11.5. We're going to knock this out in a short time. Then you're going to complete your 11.5 try on your own. Tomorrow is chapter review live for everyone there. If you got questions, make sure you got them from Mr. Myers or myself. And then between Friday, Saturday, or Sunday, you are going to need to submit your 11.4, 11.5, try on your own, and your Chapter 11 review before you complete your summative for Chapter 11 on this Monday, April 26th, all right? So here we go. Let's do a little warm-up here, and bottom line, we'll go through this together really quick. You have a 500 milliliter pitcher of lemonade that contains 30% lemonade or lemon juice plus water. Well, how many milliliters of lemon juice are in a pitcher? Are in this pitcher of lemonade? Well, 30% of the 500 milliliters. So I would take 500 times 0.3, my percent as a decimal. That is going to give me 150 milliliters of lemon juice are in that pitcher of lemonade. And how many milliliters of water are in the pitcher of lemonade? Well, that's a pretty obvious question. If there's 500 milliliters total and I subtract the 150 milliliters of lemon juice, that only leaves me with 350 milliliters of water in there. Okay, suppose the lemonade was too strong. You're like, ooh, it's pretty lemony. And another 100 milliliters of water was added to the pitcher. What is the lemon juice concentration now? Well, let's think about this a quick second. And if we think about the concentration of lemon juice, the concentration of the lemon juice, or your 30%, is going to equal your milliliters of lemon juice divided by the total milliliters of the product you have. So, bottom line, what that is saying is my concentration, I have 150 milliliters of lemon juice. Currently, I have 500 milliliters of juice and water combined, and if I only add water, well, what that's going to do is that's going to give me 150 milliliters of juice in 600 milliliters total now, because I added another 100 milliliters of water, and if I do the division there, that's going to give me 0.25 with my calculator, or it's going to be a 25% concentration of lemon juice in there. Okay, so because we added only water, we diluted the lemon juice, so it's less lemony. Okay, well, we have 3 problems we're going to go through here. We have Tracy and Adrian model the following problem with a rational function, because that's really what we can do to that little piece. Yeah, I don't have that little piece in there, but the next piece in your notes, okay, is it says recall that a rational expression is the ratio of 2 polynomials. Okay, rational expressions can be used to solve problems that involve comparing 2 quantities of the same unit measure. Okay, so basically we have Tracy and Adrian model the following problem with a rational function. Okay, now Crunchy Kid Snack Mix Company manufactures a brand of trail mix containing peanuts, almonds, and chocolate. Each package contains a total of 400 grams of trail mix with 50% peanuts, 35% almonds, and 15% chocolate. Find the current number of grams of each ingredient of the 400 gram mixture. Well, I have peanuts, and in that peanuts, of the 400 grams, I have 0.5% or 50% are peanuts, so if we multiply that by 0.5, I have 200 grams of peanuts. How about almonds? Well, of that 400 gram mixture, 35% are almonds. So 400 times 0.35, that's going to give me 140 grams of almonds. And then the best, we have chocolate. Love chocolate. I'll leave it CH. No, I'm not. I'm not going to do it. I'm going to call it, I don't want to call it chapter, so I'm going to leave it C for chocolate. And of that 400 gram mixture, we have 0.15 or 15% is chocolate, which means there's only 60 grams of chocolate in that mixture. And let's face it, Herbert, that guy, he loves the chocolate. So when he gets the bag home, he wants to add enough chocolate so the mixture is 50% chocolate. How many grams of chocolate is he going to have to add? Well, let's think about this. If he currently has 60 grams of chocolate in the 400 grams of trail mix, if you take 60 divided by 400, guess what you get? You get his current 15% of his chocolate mixture. But what this guy wants, he's just dumping in chocolate, all right? So he's gonna add chocolate, X amount of chocolate, and just think about this. This ratio is going to be chocolate over total. So if he adds chocolate to it, if he adds 10 grams of chocolate, he's going to have to add 10 grams to the entire trail mix bag, right? So then he'd have 410 grams. Well, as he's adding his chocolate, he wants this whole mixture to equal 50% chocolate. So he is diluting the peanuts, he is diluting the almonds, and he is more intensifying his chocolate. So we have a rational function here. We'll just think about this. These are like a proportion. It's a fraction equals a fraction. So what I'm going to do is I'm just going to cross multiply this bugger. So as I come across here, I'm going to take my 0.5 times 400. So really I have 400 plus x times 0.5 equals my 60 plus x, technically times 1, right? So this is going to give me 200 plus 0.5x equals 60 plus x. Well, excuse me, solving equations, I'm getting everything on one side. And this is going to give me 140 equals 0.5x. And, you know, all you decimal freaks out there, if I said, oh, if I divide 140 by a half, you're going to tell me it's 70. Well, let's look at it this way. 140, another way to see a 0.5 is a half x, right? So really, to solve this, we're going to have to multiply both sides by 2 to find out. Herbert's going to have to add 280 grams of chocolate. So he must add 280 grams of chocolate to make his chocolate mix 50% chocolate, which means he is going to have a total of, what, 680 grams of trail mix. Solid math, Mr. K. Thank you. Appreciate it. Number 2, in football, quarterback's completion percentage is the ratio of the number of completed passes divided by total passes. Okay? The current record holder for the highest completion percentage is Chad Pennington. I don't know if that statistic's true, but anymore. But he completed 66% of his passes over the course of his career in the NFL. The quarterback in second place has 3,843 passes out of 5,853 attempts. Estimate the number of consecutive completed passes the second place quarterback must throw in order to break the record. Well, right now, he currently has 3,843 completed passes out of 5,853. Okay, and he is in second place. And what we want to do is we want to say for every basically for every pass he throws, it's a completed pass because it's consecutive completed passes. So every pass this number 2 makes, it's going to be a completed pass. And how many consecutive completed passes does he have to get to match the 66%? Well, this is going to be the same deal we did before here. And we're going to hopefully just look at this like a proportion. And if I cross multiply, I'm going to have my 380.43 plus x. Remember, that's going to be times by 0.66. And that's going to equal my 5853 plus x. And that's going to be multiplied times 1. Well, if I distribute that, what am I getting? Hold on here, Kruger. You just botched something here. Yeah, hold on. That's bad cross multiplication. Come on, Kruger. Let's really figure this business out. We're cross multiplying, so we're taking 0.66 times 5853 plus x. That is equaling my 1 times 3843 plus x. There we go. Now we're saddling this little bugger in here. So as we do this, as I distribute x, we are going to have 3862.98 plus 0.66x equals 3843 plus x. Well, we got to get x's by themselves, right? So hopefully what we're going to do is we're going to subtract this 0.66x from this 0.66x. And we're going to subtract this 3843 from this 3862. And when we do that, what we're going to come up with is 0.34 x's actually equals 19.98. So if I divide by my 34%, or my 0.34, x is going to be about 58.76 completed passes. Now, you can't throw 58.76 consecutive passes. So we either need to round up or we need to round down. What are we going to do? Well, we want to beat the 66%. So if we round it down to 58, his pass completion is going to be less than 66%. So we would have to round up and say he needs to complete 59 passes. And if he does 59 consecutive passes, no incompletions, he will now be in first place, right? Odds are not in his favor. But if he did it, he's now in first place. Last problem we got here, this is like comparing something someday you might end up doing. And I know you're all going to say, oh, I'll just pay somebody to do that, or I really don't care, it doesn't matter. But here we go. Josie compares 2 different refrigerators at the local hardware store. And sales tags are shown. Well, someday when you guys go buy appliances, you're going to find out you do have energy efficiencies, okay? And the more energy efficient something is, the more expensive it typically is to manufacture it. And the less efficient it is, the cheaper it is to manufacture. So if you buy a cheaper item, it's going to use more electricity than the more expensive item typically will use less, okay? So what we are going to do, Josie's going to do some research online, and she learns that kilowatt hours in her region are about 6 cents. Okay. She also learns the average refrigerator lasts about 10 years. That there, 10 years for a refrigerator, that's a fact. Some last longer, some last less, but on average, it's 10 years. Found that one out myself. Mine died a few years ago. Okay. And we're going to write a function to represent the average cost for each refrigerator. Well, if I look at icy cold, my icy cold average cost. Well, let's think about this. So I'm gonna have a function f of x, and average cost per month. Now, what we need to do is we need to add up our total cost for all the months and then divide by how many months we have, right? Well, bottom line, it's going to cost us $699 to purchase this refrigerator. But that's not it. These things cost even more because every month we got to add, okay, it's going to be 75 kilowatt hours that thing's going to use. Each kilowatt hour is 6 cents, and we're going to be paying that charge recurring every month. And if we divide that by X months, we will have our average cost, okay? So my cost for icy cold f of x is going to be $699 plus, well, how much per month is this one going to cost you? Well, 75 kilowatt hours times 6 cents, that's going to cost you $4.50 each month on your bill. And if you divide it by how many months you have that refrigerator, you will have your average cost. On the other hand, over here, we have cool as a cucumber. Okay, and cool as a cucumber, this is a much more expensive refrigerator. And I can't call it f of x, so I'm going to have to call it g of x. I'm going to have to call it a different function, otherwise they would be the same, and they're not. So cool as a cucumber, I know, is going to cost me 825 bones to start out. And this one's a little bit more because here it's only 30 kilowatt hours per month times 0.06 cents. My kilowatt hours still cost me the same, it doesn't matter, times X months. And I'm going to divide it by X months. And that's going to give me my average cost. So cool as a cucumber is going to cost me my initial investment of $825 plus 30 kilowatt hours times 6 cents an hour. This one's going to cost me $1. Sorry for the little interruption we had there with the PA going on, but cool as a cucumber costs you $825 initial investment, but your 30 kilowatt hours times 6 cents, this one's only going to cost you $1.80 per month to run, and we're going to divide it by X months to find out what our average cost is. Well, you know, when you're tallying up a lot of months here, $4.50 as opposed to $1.80, over time that ends up being quite a bit. So which refrigerator will have a lower average monthly cost over the next 10 years? That is saying, in the end, in 10 years, how much, which one is going to be cheaper for you to purchase and hold on to for 10 years? Well, remember, electricity we pay monthly, so 10 years, that's 120 months. So if we need our average annual cost, or our average monthly cost, we're going to take our icy cold and we're going to put 120 months in, and we're going to find out that one costs us $699 initially, plus we're paying $4.50 every month for 120 months. And we're going to sum up our total cost there. That top is our total cost, and we're going to divide it by the 120 months we have. And we are going to find out our icy cold refrigerator, when we do the math on that, that's going to cost us $10.33 per month. Okay? How about Mr. Cool as a Cucumber? Well, that's taking and putting 120 in for that. Remember, Cool as a Cucumber is more expensive at $825 a month, but it's only costing us $1.80 for 120 months. So there, right there, if I put that in, that's my total cost of having that for 10 years or 120 months. And if I divide it by my total of 120 months that I had it for, this is going to give me my average monthly cost over 10 years, which is going to be Cool as a Cucumber, is going to cost me $8.68 per month. Okay, so which one is going to have the average, a lower average monthly cost? Obviously, it is the Cool as a Cucumber. Okay, you pay more for it up front, but for every month from there on out, you pay less for it. And someday you guys will be making these little subtle calculations, and some of you might be making so much money, you're like, it don't matter, I don't care how much I spend. But if you ever do it, this is how we're going to do it. So from here on out, guys, you have a worksheet to do, 11.5, try on your own. Once you get that bugger done, you got any questions, reach out, and tomorrow is review day. Hey, have a great rest of your day.